At 8:01 in the morning, the port side plating of the USS Utah failed under the impact of Japanese aerial torpedoes. The ship was not struck by a chance accident or stray fire. She was deliberately targeted by 6 Nakajima B-5N torpedo bombers launched from the Japanese carrier Soryu. This attack initiated a catastrophic chain of events that would conclude exactly 11 minutes later with the total inversion of the vessel. The destruction of this ship provides a distinct case study in naval identification errors and the physics of rapid stability loss. The pilots from the Soryu were operating under strict procedural constraints. Their pre-flight briefings explicitly prioritized active capital ships, particularly aircraft carriers and battleships. They were briefed to prioritize high-value warships, which made the attack on Utah consistent with an identification error rather than a deliberate strike on a training ship. The USS Utah was a demilitarized target ship designated AG-16, yet she drew the focused attention of an entire flight of torpedo bombers. This targeting decision was a technical error driven by visual misinterpretation. The Utah retained the hull lines of a Florida-class dreadnought battleship. From the air, her modified deck configuration and the heavy timber structures built over her turrets gave her the profile of a modernized super dreadnought. The pilots identified her as a high-priority threat and committed their weapons to a target that possessed no offensive main battery and no heavy armor belt. The physical consequence of this identification error was immediate. At least 2 Type 91 aerial torpedoes struck the port side below the waterline. The damage opened the hull to the sea, creating a massive influx of water into the port, wing tanks, and boiler rooms. This created a condition known as asymmetric flooding. In a controlled scenario, damage control teams would counter-flood the starboard voids to balance the weight and keep the ship upright. On the Utah, this was chemically and operationally impossible. The ship had been stripped of her heavy active defense systems, and her damage control readiness state was set for a training environment, not combat. The water rushed into the port side faster than any countermeasure could compensate. As the port side weighed down, the center of buoyancy shifted starboard. The righting arm, which is the force that naturally returns a ship to an upright position, decreased rapidly. Within minutes, the list passed the critical angle of maximum stability. Once a hull rotates past this geometric threshold, the ocean takes over. The ship began to roll relentlessly to port. The massive tripod masts and the remaining turret structures acted as levers driving the rotation faster. By about 8:12, the ship had rolled over to port and capsized. She did not sink to the bottom in an upright orientation like the USS Arizona. She turned turtle, causing her superstructure to dig into the harbor floor while her keel rolled into the air. The speed of the capsize trapped many officers and men inside the hull. The physics of the event were absolute. 11 minutes was insufficient time for the crew below decks to navigate the complex internal passageways of a capsizing vessel. The wreck stabilized in this inverted position. The hull prevented any immediate access to the interior. Unlike other vessels that settled into the mud upright, the Utah presented a unique salvage engineering challenge. She was not just a sunken ship, she was a capsized obstruction blocking a valuable berth on the north side of Ford Island. The Navy was left with a 21,000-ton steel island, effectively creating a navigation hazard in the middle of a war zone. The initial assessment was cold and pragmatic. The ship had no military value as a fighting unit, but the berth was essential. The decision was made to attempt a recovery operation, not to return the ship to service, but to clear the harbor. This set the stage for one of the most difficult and ultimately frustrating salvage efforts of the Pacific War. The engineers would not be fighting the enemy, but rather the friction coefficients of the Pearl Harbor mud. To understand why the loss of the Utah became an irreversible worst-case scenario, one must examine the specific modifications made to her deck plating. The ship that occupied berth Fox 11 was not configured as a standard combat vessel. Since 1931, the Utah had served in a demilitarized role. Her designation was changed from BB-31 to AG-16, signifying her conversion into a mobile target. This change in mission required a fundamental alteration to her naval architecture known as target hardening. Target hardening is the engineering process of reinforcing a structure to absorb repeated kinetic impacts without sustaining critical structural failure. For the Utah, this meant she had to survive being struck by water-filled practice bombs dropped from high altitude. A steel deck is rigid and brittle when subjected to direct vertical impact. To prevent the practice ordnance from punching through the armored deck and damaging the delicate machinery below, the Navy installed a buffer system. This system consisted of a massive timber mattress laid directly over the weather decks. The specifications for this protective layer were substantial. The engineers utilized heavy balks of timber measuring 6 inches by 12 inches. These were not merely placed on the deck, they were stacked in 2 distinct layers across the entire exposed surface of the ship. In certain areas where damage had been frequent or severe, crews added concrete patches to plug the gaps, creating a heavy composite sandwich of wood, steel, and cement. This configuration was highly effective at absorbing the vertical energy of a falling practice bomb. However, it was never designed to function at a 90-degree angle or an inverted orientation. When the asymmetric flooding described in the previous chapter forced the ship into a rapid roll, the physics of the timber mattress changed instantly. The heavy timbers were held in place by gravity and friction designed to resist downward force. They were not bolted down to withstand lateral shear forces or inversion. As the ship rotated past 45 degrees, the friction failed. Tons of heavy lumber broke loose from the steel decking. This shift created a chaotic internal environment. The loose timbers effectively became an avalanche of heavy debris sliding across the deck. For the crew members attempting to escape from the lower compartments, the sliding timbers became a physical barrier. Hatches and scuttles that were the primary escape routes were buried under layers of 6 by 12-inch beams. This debris field did not just trap men, it also hampered the initial rescue efforts. The clutter obscured the hull openings and created a hazardous environment for any diver attempting to penetrate the wreck immediately after the sinking. The lethality of the event was compounded by the internal modifications associated with her role as a gunnery training ship. While the main 12-inch guns had been removed, the ship was fitted with a complex array of anti-aircraft weaponry for gunnery students. These positions included the new 1.1-inch quad mounts, often called Chicago pianos. To protect these guns from the practice bombs, large steel sheds known as doghouses were constructed over them. These structures added top weight to the ship, raising her center of gravity. While this did not cause the capsize, it certainly accelerated the roll once stability was lost. By the afternoon of December 7th, the Utah was resting firmly in the mud. The target hardening that had protected her for a decade had contributed to the entrapment of her crew. The Navy now faced a difficult engineering assessment. The ship was upside down with her superstructure crushed into the harbor bottom. The timber mattress was now pinned between the hull and the mud. The salvage officers had to decide whether the hull could be righted or if it should be cut apart piece by piece. The decision was driven by the urgent need for harbor space. The berth was needed for active ships, and the Utah was in the way. They chose to attempt a recovery utilizing a method that relied on brute force rather than disassembly. The salvage engineers facing the inverted hull of the Utah had to select a recovery strategy from 2 distinct options. The first option was to cut the ship into sections underwater and remove it piece by piece. This method was technically feasible, but operationally expensive. It required thousands of hours of diver bottom time and involved high risks of cutting accidents in the murky water. The second option was to rotate the ship back to an upright position using external force. This would allow the hull to be refloated and towed away intact. Driven by the urgent need to clear the berth with minimal diver exposure, the Navy selected the second option. The engineering principle chosen to execute this rotation is known as parbuckling. In a standard parbuckling operation, engineers wrap cables around a cylindrical object and pull from the shore. This converts linear tension into rotational torque. However, a battleship is not a perfect cylinder. To generate the necessary leverage on the Utah, the salvage teams constructed a series of timber structures called bents along the exposed starboard side of the hull. These bents acted as lever arms extending the radius of the pull. The cables ran from the shore up over the top of the bents and attached to the high side of the ship. This geometry ensured that when the cables tightened, the force would pull the hull over rather than just dragging it sideways. The scale of the operation required immense power. The Navy needed to generate enough torque to overcome the inertia of 21,000 tons of steel, plus the suction of the harbor mud. To provide this force, they installed a battery of high-capacity electric compound winch systems on the shore of Ford Island. These machines were set in heavy concrete foundations specifically poured to resist the horizontal load of the pull. This brings us to a critical logistical detail regarding the equipment. The United States Navy did not manufacture a new set of winches for the Utah. The salvage teams used righting gear previously employed on USS Oklahoma, redeploying winches and rigging at Pearl Harbor to roll Utah partially upright. Once the Oklahoma was upright, the salvage teams dismantled the winches, transported them down the shoreline, and reinstalled them facing the Utah. This reuse of heavy industrial machinery demonstrates the resource constraints of the era. The Pacific Fleet could not wait for new equipment to be shipped from the mainland. The salvage division had to operate as a self-sustaining industrial unit, cannibalizing its own success to tackle the next problem. The setup phase was labor-intensive. Divers had to tunnel under the hull to secure the cable attachments while surface teams constructed the 17 timber bents on the slippery, oil-soaked plating. This work was complicated by the target hardening modifications discussed in the previous chapter. The concrete patches and timber layers added unpredictable weight distribution to the hull, making the center of gravity difficult to calculate with precision. The engineers had to assume the hull would behave like a standard vessel despite these heavy accretions. By early 1944, the system was fully rigged. 17 steel cables stretched from the Ford Island shore over the timber bents and anchored to the ship. The plan relied on a specific interaction with the seabed. For the parbuckling to work, the port bilge of the ship needed to act as a pivot point. The hull had to bite into the harbor bottom, creating enough friction to hold the lower edge in place while the winches pulled the upper edge over. If the friction was sufficient, the ship would roll. If the friction was insufficient, the physics of the operation would change entirely. The engineers powered up the recycled winches and began to apply tension, watching the cables tighten against the massive resistance of the capsized dreadnought. The fundamental equation of the parbuckling operation relied on a delicate balance between two opposing forces. On one side was the rotational torque generated by the 17 electric winches on Ford Island. On the other side was the coefficient of friction between the steel hull of the Utah and the harbor floor. For the ship to roll upright, the friction at the bilge had to be stronger than the lateral force pulling the ship toward the shore. If the friction held, the ship would pivot. If the friction failed, the ship would slide. As the tension on the cables increased, the engineers observed a critical failure in this equation. The hull did not rotate around a fixed point. Instead, the entire vessel began to translate horizontally through the mud. The massive winches were effectively dragging the 21,000-ton ship closer to the beach. The parbuckling geometry collapsed because the seabed at berth Fox 11 failed to provide the necessary resistance. This failure was driven by a mechanism known as mud suction and soil shear. The bottom of Pearl Harbor is composed of soft, unstable silt and sediment. When a heavy object like a battleship settles into this medium, it creates a suction bond. However, the sediment itself has very low shear strength. When the winches applied millions of pounds of force, the mud did not provide a solid backstop for the hull to pivot against. Instead, the soil sheared away, allowing the ship to plow through the bottom sediment rather than rolling over it. The behavior of the hull was further complicated by the irregular distribution of mass caused by her target history. As previously noted, the deck was a patchwork of timber and steel. Aerial surveys and inspection reports confirmed the presence of large concrete patches installed to repair bomb damage during her active service. These concrete plugs added significant dead weight to the structure but did not contribute to structural rigidity. This non-standard weight distribution meant the center of gravity was not where it would be on a standard Florida-class battleship. The engineers were pulling against a dead weight that was hydrodynamically and structurally unpredictable. The consequences of the slide were immediate and irreversible. As the ship dragged closer to Ford Island, the angle of the cables changed. The vertical lifting component of the pull decreased, while the horizontal dragging component increased. The more the ship slid, the harder it became to roll. The operation entered a diminishing returns loop where applying more power only worsened the geometric alignment. The salvage master captain Homer N. Wallen recognized that the physics were working against a successful recovery. The winches managed to rotate the ship partially, but the slide prevented a full righting. The vessel came to rest at a list of 38 degrees to port. She was no longer capsized, but she was far from upright. The ship had cleared the immediate navigation channel, but she was now effectively wedged in the mud closer to the island than before. This angle of 38 degrees represented a hard mechanical limit. To correct the list further would require resetting the entire system, moving the concrete winch foundations, and dredging a trench to allow the bilge to drop. The initial plan had failed. The ship was not upright, she was not afloat, and she was not recovered. The engineering team stood down to assess the situation. They had applied the same force and the same machinery that had successfully righted the USS Oklahoma, but the variable of seabed friction had produced a radically different outcome. The Utah was now stuck in a structural limbo, neither fully lost nor fully recovered. By March 1944, the salvage of the Utah had reached a definitive administrative boundary. The ship was resting at a 38-degree list, partially embedded in the mud and dangerously close to Ford Island. The physical slide described in the previous chapter had negated the Parbuckling strategy. To continue the operation, the engineering teams would need to reset the 17 winches, dredge a relief trench on the shoreside, and apply significantly more force to break the suction bond. This requirement triggered a high-level review of the project based on the cold logic of salvage economics. Salvage economics is the governing principle that dictates whether a recovery operation proceeds or terminates. It is a strict ratio comparing the resource cost of the recovery against the utility value of the recovered asset. In 1941, the imperative had been to clear the berth and return hulls to service. By 1944, the United States industrial machine was producing new Essex-class carriers and fast battleships at a rate that rendered the 21,000-ton Utah obsolete. She was too old to fight and too damaged to serve as a target. The only remaining value in the hull was the scrap steel. The director of the Pacific Salvage Division calculated the projected man-hours required to correct the 38-degree list. The cost in skilled labor diver risk and equipment wear exceeded the monetary value of the scrap metal that could be reclaimed. The equation was negative. The berth at Fox 11 was partially obstructed, but the ship was stable and no longer blocked the main channel. Consequently, the Navy issued a stop order. The winches were dismantled and the cables were cut. The Utah was officially declared a non-recovery loss. This decision left the ship in a state of permanent partial rotation. The visible evidence of this aborted effort remains the most distinct feature of the wreck site today. When the ship rolled, the steel sheds built over the anti-aircraft guns remained attached to the deck. These structures, known as doghouses, were originally installed to protect the gun crews and mechanisms from rain and spray during training exercises. In a standard sinking, these light metal shacks would likely have been crushed or torn away. However, due to the gentle nature of the slide and the incomplete rotation, the starboard doghouses survived. Today, these doghouses breach the surface of Pearl Harbor. They appear as rusting geometric boxes jutting out of the water. For the casual observer, they are often mistaken for the hull itself or parts of the superstructure. In reality, they are merely the protective covers for the 1.1-inch guns that never fired a shot in anger. They serve as the unintended tombstones of the vessel, marking the exact limit of the failed Parbuckling attempt. If the winches had succeeded, these structures would have been rotated back to the vertical and likely scrapped. Because the friction failed, they remained fixed at a 38-degree angle, essentially frozen in the exact moment the money ran out. The termination of the salvage effort had a secondary legal consequence. Because the ship was not recovered, the bodies of the 58 crew members were not retrieved. The cessation of work transformed the site from an active industrial zone into a static geological feature. The hull was no longer a problem to be solved, but a permanent fixture of the harbor floor. The Navy stripped the accessible above-water portions of valuable non-ferrous metals, but left the bulk of the ferrous steel structure intact. The Utah had transitioned from a priority target to a salvage failure and finally to a rejected asset. This status of abandonment set the conditions for her final designation not as a ship, but as a protected sovereign site. The USS Utah currently lies along the northwest side of Ford Island with her starboard deck edge buried in the sediment and her port bilge exposed to the air. The list remains fixed at the 38 degrees established when the winches were halted in 1944. While the physical structure is defined by corrosion and structural fatigue, the site is defined by a strict legal boundary known as a war grave. A war grave is not merely a commemorative designation. It is a specific status under international admiralty law and United States naval policy. It asserts that the wreck is the final resting place of military personnel and is therefore subject to sovereign immunity. This legal framework prohibits unauthorized diving salvage or intrusion. For the Utah, this status is the primary reason the hull remains in place today. Inside the inverted compartments of the vessel, the remains of 58 officers and men are still entombed. Because the 1944 operation was a failure rather than a forensic recovery, the Navy never accessed the interior spaces where these men were trapped. The decision to leave the ship was originally economic, but today it is ethical and legal. The existence of this site presents a stark contrast to the ship's operational history. Before she was a static tomb, the Utah was the most technologically advanced test platform in the fleet. As noted in the dossier, she was the first American ship to be fitted with remote control gear acting as a robot ship piloted by radio signals. This vessel, which once represented the cutting edge of naval automation, is now a slowly disintegrating iron oxide structure. The technology that made her unique is now rotting inside the hull, protected only by the turbidity of the water and the prohibition against entry. The deterioration of the wreck is constant. The steel plating of the Florida class was manufactured in the early 20th century and has been submerged in salt water for over 80 years. The doghouses in the exposed port side are thinning due to oxidation. As the metal weakens, the structure will eventually lose the structural integrity required to maintain its current geometry. However, the Navy has implemented a policy of non-intervention. There are no plans to stabilize the hull or to resume the salvage. The previous application of salvage economics determined that the ship was not worth the cost of removal. That equation has not changed. The cost to remove the wreck now would be measured not just in dollars, but in the disruption of a biological reef system and the disturbance of human remains. This leaves the Utah in a state of permanent suspension. She is often overshadowed by the USS Arizona, which lies on the other side of Ford Island. While the Arizona receives millions of visitors, the Utah remains isolated, accessible only to those with military access or specific authorization. This isolation is a direct consequence of her location and her lack of a catastrophic magazine explosion to draw historical attention. Yet the legal protection remains identical. The salvage cables are gone. The winches have been removed for nearly a century. The timber bents have long since rotted away. All that remains is the hull itself, held in place by the mud that refused to let go. The failure of the Parbuckling operation ensured that the Utah would not be scrapped. Instead, it preserved the ship as a complete, if inverted, time capsule. The men who died inside remain at their posts, and the ship remains at her berth. The operation that began with a torpedo impact at 8:01 on December 7th ended not with a recovery, but with a quiet acceptance of the limits of engineering.